In this video, I'm going to solve this question. You may consider this question as a continuation to the last video only. So before you watch this video, make sure that you have gone through the last video. Let's start this question now. In how many different ways can the letters A, B, C, D, E, F be arranged such that A and E are never together? I'm going to show you two methods to solve this question. Make sure you understand both the methods well because both the methods are equally important. So let's start with our first method, which is quite simple in this case. So we have to find the number of ways to arrange these 6 letters such that A and E are never together. Well, this is simple. To find this, all you have to do total number of ways. So total number of ways minus all those ways where A and E are always together. So minus the ways where A and E are always together. And that's it. Because you have to find the number of ways where A and E are never together, the simplest possible way to find this is to do total number of ways minus the ways where A and E are always together, and this will give you your answer. So let's complete this. So by total number of ways, I mean the total number of ways in which you can arrange these 6 letters without any condition. So we know that these are 6 different letters. So without any condition, these 6 different letters can be arranged in 6 factorial ways. And we have already found the number of ways in which we can arrange these 6 letters such that A and E are always together. We found this in the last video. And the answer that we got was 5 factorial multiplied by 2 factorial. And once you solve this, you will get that this is equal to 720 minus 120 multiplied by 2. So this is equal to 720 minus 240 equal to 480 ways. So that's the answer. So this was your method number 1, and it was quite simple in this case because we already had information about this because we solved this in the last video, and finding this was quite simple. But you may encounter some of the questions in which working in this manner might not be this straightforward. So let's have a look at method number 2, which is equally important. Method number 2. See, we want that A and E should not be together. So if we don't want A and E to be together, there are many possible cases that we can have. For example, we could have A at the first place, E at the 5th place, or we can have A at the 2nd place, E at the 6th place. So there are many possible cases that we can have, and it is not possible that we create each case separately and then solve for it because there will be many cases and there is a high possibility that you end up skipping some particular case. So let me tell you a shortcut approach to take into account all the possible cases that we can have. So first of all, what we have to do is that write the letters on which we do not have any condition separately. So let's use purple color and let's write B, C, D and F separately. So these are the 4 letters on which we don't have any condition, and let's write A and E separately. These are the 2 letters on which we have conditions. So first of all, let me start by arranging these 4 letters. So what I'm going to do is I'm going to fix these 4 letters at alternative slots. So this is what I'm trying to say. Let's create 9 slots. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And what I want to do is I want to fix these 4 letters at alternative slots. So B here, C here, D here and F here. And I'm doing this because I do not want A and E to come together. Note that by writing things in this manner, I am indirectly incorporating all the possible cases that you could think of. So for example, let's say that you have come up with a case where A is taking the 3rd place and E is taking the 5th place. So if A is taking the 3rd place, all you have to do is you have to write A here and you have to write E here. And this will become B, C, A, D, E, F. So A is taking the 3rd place and E is taking the 5th place. Similarly, if you want A to take the 1st place, you can write A here. So I can write A here and you can remove A from here. And if you want E to take the 3rd place, you can write E here and you can remove the E from here. And in this way, what we will get is A, B, E C, D, F. So if I write these 4 letters in this way, I'm indirectly incorporating all the possible cases that we could have. Now let's proceed with this. So let me write that total number of ways is equal to, so we have to find the total number of ways such that E and A are never together. So total number of ways where A and E are never together. So this is equal to, now first of all note that I have fixed the slot for my letters in purple. I can still rearrange them in 4 factorial ways, right? So I can, instead of B, write C, instead of C I can write D, and whatsoever. So the number of ways in which I can arrange these 4 purple letters is 4 factorial. So now we are done with all the talking about these letters in purple. Let's switch to the letters that we have written in the yellow color. So that means the letters A and E. Now let's talk about in how many ways can we insert A and E into these spaces. Well, this is simple. There are 5 spaces. So if we start with A can take any of these 5 spaces. So A can take any of these 5 spaces, and once we give 1 space to A, E can take any of the remaining 4 places. So this is the number of ways in which we can insert A and E into these spaces. So this is the total number of ways to arrange the letters in purple, and this is the total number of ways to arrange the letters in yellow. Now we have to arrange the letters in the purple and the letters in yellow. So that means we have to multiply these two. So this implies that your answer is 4 factorial multiplied by 5 multiplied by 4. And 4 factorial is equal to 24, and this is 20. So this is equal to 480 ways, and this is the answer. Note that I'm not done yet. There are still a couple of things that I have to tell you, so pay attention. So basically, first of all, let's summarize what have we done in this method. So what we have done is we first wrote the letters on which we do not have any conditions separately, and then we wrote the letters on which we have conditions separately. And then we fixed the letters in purple in this manner and found the number of ways in which we can arrange the letters in purple. And once we fix the letters in purple in this manner, then we talk about how can we insert the letters in yellow into this arrangement. And then we found this. And because you need to arrange all the letters, that is the letters in yellow and the letters in purple, so you multiply these two and you get your answer as 480 ways. Now before I end this video, there is one last thing that I want to tell you, and that is about how to find the number of ways to arrange the letters that we have in yellow color. So basically right now we know that the number of ways to arrange A and E are 5 multiplied by 4, but I deliberately want to tell you one more way to find this using the method of permutations. So let's see how can we find that. So basically what we have here is that we have to insert A and E into this expression. So that means out of the 5 available spaces that we have to select 2 spaces, and the ordering is going to matter in this case. This is because if I select the first space for, let's say, A, and let's say I select this space for E, then if I interchange this, we will get different outcomes. So the thing is that out of the 5 available spaces, I have to select 2 spaces, and the ordering is going to matter. That means in terms of permutations, we can write that the total number of ways in which this can be done is 5p2, which is equal to 5 factorial divided by 5 minus 2 factorial, and this is equal to 5 factorial divided by 3 factorial, and this is nothing but 5 multiplied by 4. So you obviously get the same answer, but it's just that I wanted to show you this formula way as well so that you could keep this in mind. So with this, I'm done with this question. Now before you move to the next question, make sure that you have developed a good understanding of both these methods, especially the method number 2. It is extremely important. Also, I'm going to use this method number 2 in solving many other questions as we proceed further. So this is all for this lecture.